Okay, hi everybody. Can you listen me?
Yes.
Yeah.
Okay, perfect. Okay, let me just put the phone. Okay. Well, for today, I'm going to say like everyone was here, so I will put like assistance to everyone. So okay, let me just what? Okay. Okay. Well, basically, like today, we are going to review more problems close to the exam that we are going to have on Wednesday. So, okay, let me start with that. Let me just see the document. Let's see what can we do. Okay. Okay, let me share a screen with you guys.
Sorry, teacher. I just had some trouble with internet and things. I was a little late.
Don't worry, Ginger. Okay, we are just going to start. I'm going to like share my screen so you can like start seeing the process. Basically, like today we are going to cover like a review in order to have the really good our exam. Okay, can you see like my like the share like my iPad?
Yes.
Yes, teacher.
Yes, teacher.
Okay, thank you. Okay, for example, if you remember, we saw like something about like true and false questions. Okay, maybe let's do it fast and see like more of the problem. This is the homework that I left you. We are going to see like some of the homework and some of the problems really close to the ones that we are going to have like in the exam. So you can like have a really good idea of what you're going to have. But well, let's first review what we said. Okay, for example, true and false question, negative acceleration means that you increase velocity. This is false, right? Because if we remember negative acceleration, it means that you are decreasing your velocity, you are not increasing. So, okay. And the second one, if you throw a ball down from a 500 meters building with a v0 of 5 meters per second, will the final velocity be vf equals 0 meters per second? Basically, they are giving you like a lot of details in order that you start like losing time with calculations, but you know that this is false. Why? Because if you throw a ball with an initial, first of all, it has like a initial velocity that is negative, right? And we also have like an acceleration that is also in the same sense. So this g, it will increase even further the velocity, right? So there's like no way that this one can be 0. So this is false. Okay, in this one, they are asking you distance is a vector and displacement is an scalar. This is also false because they are like changed. They are, if you know, distance is an scalar and displacement is a vector, right? So they should be like in the opposite. Okay. 4, if you have a constant acceleration of 10 meters per second square, after 10 seconds, you will have a velocity of 100 meters per second. This one is true. Why? In here, you have to make, in fact, like a little small calculation. If you remember the velocity, right? It was also like final velocity is equal to v0 plus a times t, right? We do not have, they are not giving us like an initial velocity, so we can assume that this is 0, right? And they are giving us, in fact, an acceleration, a constant acceleration of 10 meters per second. So this will be 10 meters per second squared, right? And multiply, he said that after 10 seconds. So we are going to multiply 10 seconds, right? And we are going to have 100 meters per second, right? We can send this, okay? So they are giving us, like, the final velocity will be 100 meters per second. Yes, it's true. Okay. In this one, okay, in here, you in fact have to do like more procedure. Well, these two are like, if you see, they are related. So you first have to solve like for 5, and then you can do 6. Okay, let's start with that. Okay, it says if I am driving at 160 kilometers per hour. Like, remember, when we have this type of problems of velocity in kilometers per hour, what's the first thing that we have to do? Like, pass it to meters per second, right? So the 160 kilometers per hour, we have to translate it to meters per second. In order like to start doing the calculation, because if you remember like the formulas of distance, of acceleration, they are always like in the base units. Like most of physics, always you have to like translate the units in the base units, because the formulas just work like if you have like the same base units. Okay, so 160 kilometers per hour. If you remember, there are like two ways of doing it. The long way is the unit conversion, right? If you remember, 1 kilometer is equal to 1,000 meters, right? And we want to eliminate kilometers, so we have to put the kilometers down and the meters up, right? And the other is the hours. We want to eliminate hours. So, okay, 1 hour is going to be up, and we have 360 seconds, right? 2,600 seconds. Okay, after doing this, we have that 160 times 1,000 divided by 3,600 is going to be 44.44, right? Okay.
Teacher.
Yeah.
In there, we can just also multiply 1 over 3.6, right?
Yes, exactly. Also, you said, you. It's like this is the long way, and the shortcut, as I told you, it was 160 kilometers per hour multiplied by 1 over 3.6, right? This is when you are going from kilometers per hour to meters per second, right? If you were like in the opposite way, from meters per second to kilometers per hour, it's going to be, well, this is 1 over 3.6, right? And here is 3.6. But almost always, like at least in high school physics, it's going to be this way, like from kilometers per hour to meters per second. Why? Because as I told you, like the formulas in order to, like to work, they have to be in the base units. So, okay, that's basically the main reason. If we translate it, it was 44.4 meters per second, the velocity, right? Okay, and we have an acceleration. They are giving us an acceleration of -5 meters per second squared. So this means that we are going to reduce our acceleration, right? Okay. Let's see. In order to know, for example, the time where we will be like completely stopped, because yes, in order like not to crash, we have to stop like continue advancing, right? Because it says like the problem. If I am driving at 160 kilometers per hour and I press the brake and I have a constant acceleration of -5 meters per second squared, will I crash if I have to stop in 5 seconds? First of all, like we have to know when are we going to be like completely stopped, right? So we have to know the time when our final V is going to be 0 meters per second, right? So, okay, if we remember, it was B, T, right? So, okay, in order to know the T, we have to have B over A, right? And we said that our V is 44.4 meters per second, and our A is 5 meters per second squared. I know that it's negative, but in this case, like we have to take like the absolute values because we cannot have like negative time. At least not in high school physics. And okay, let me put it. Okay, so basically we have to divide 44.4 by 5, and this is going to be 8.8 seconds, right? 8.88 seconds. So if we have to stop in 5 seconds, what do we know? If we need 8.88 seconds in order to be completely stopped. So yes, I will crash if I have to stop in 5 seconds. So this is true. I will crash. Okay. And the second question, it said like, what about 10 seconds? Okay, it's going to be false because for this time, we will be completely stopped at 8.88 seconds, right? So 10 seconds is like longer than that time. So yes, we will be completely stopped after that time, right? Okay, so we will not crash. Okay, the next question, it says the velocity is defined as the change of displacement with respect to time. This one is true, if you remember, right? Okay. And the last one is just like in order for you to know what are the units of acceleration. Okay, the units of acceleration are meters per second in the international system. This is completely false because if we remember the units of acceleration, they were meters
Meters
over
per second squared.
square, right? Perfect. It was meters over second square. And here is just meters per second. In fact, these are the units of velocity, right? Not acceleration. So this is going to be false. Okay, well, let me say something a little bit about before starting this problem. Definitely problem 1 in here is the hardest, and it's even, I think I will say like it's even above the level of the exam. So maybe we can do a little bit, like I will not solve it all because it's in fact like really long. And in fact, it's like above the level of the exam. So let me just do like maybe 5-10 minutes of this. And then I will start like doing problems that are more close to the exam. But okay, this one, like if you know like to do this one for sure, you can like really do really good. But in fact, this one is much harder than the one that you're going to have in the exam. Okay. Okay, let's see. Maybe this is even high school, like in college level, but okay. Okay, first of all, it says, well, first of all, if you remember when we have kilometers per hour, what the first thing that we have to do? Like when we have to convert it to meters per second, right? Okay, so for example, well, let's read the problem a little bit. It says, Checo Perez wants to win a race. He is in the second place, driving at 250 kilometers per hour. And the first place, Lewis Hamilton, is at 260 kilometers per hour. Checo starts accelerating at 4 meters per second square, but he is in the last 100 meters. Will he beat Hamilton? Okay. First of all, let's see what's the original velocity of Checo. Okay. We have 250 kilometers per hour, but we have to translate it to meters per second. Okay, for example, doing the shortcut, it will be 250 times 1 over 3.6, right? Okay, doing that.
It's a 69.44.
Thank you. It's going to be 69.44 meters per second, right? Okay, 69.44 meters per second, right? And the initial velocity of Hamilton, we know that is 260 kilometers per hour, right? So kind of the same. We are going to multiply 260 by 1 over 3.6. And this is going
And it's 72.2.
perfect 72. It's going to be 72.22 meters per second, right? Okay, we now have both initial velocities. Okay, in fact, in here, they make a mistake. Then they put the distance between Hamilton and Checo. So, for example, we can do like two cases. For example, maybe first case is going to be that the difference of distance between Hamilton and Checo is, I don't know, let's say 10 meters. And the other one, let's say that it's 0 meters. They are the same level, right? So it's going to be 2. Okay. First of all, let's see like the formulas that we have, right? Okay.
Teacher, just one question.
Yeah.
Where did you got the 10 meters?
Sorry, what?
Where did you got the 10 meters? You said
No. Like they didn't put it like because
just in case.
Yeah, it was a case. It's a case.
Okay.
Because when we know, okay, let's see, like continue with the problem. We
Okay,
have an
teacher.
acceleration, right? It says that Checo starts accelerating. So the acceleration of Checo is 4 meters per second squared. The acceleration of Hamilton, they didn't put it, but it was 0. Like it has the same velocity, right? That's why it's a possibility that Checo can win to him, right? We don't know yet. We have to do like the complete calculation in order to know it. But okay, we have these two accelerations, right? Of two different objects. We have to take into account that they are not like in the same object. They are in different, like one is the car of Checo and the other one is in the car of Hamilton. Okay, this part is the distance that Checo has in order to win to Hamilton, right? It just have 100 meters, right? Why is this important? This one it's important because as I told you, like if you remember, like in last class, Friday, we were seeing the how to solve second degree equations, right? If you remember the formula, I will put it like in the exam, don't worry much about that. Right? Okay. Why? Because if we remember the formula of the distance, it was okay. Right? Okay. Let's see what do we have. Okay, for example, let's do it for Checo. First case, Checo. All right. The distance we have dt in this case is going to be 100 meters. They are giving us that the final distance or the maximum distance that it can happen Checo, right? Is right. Okay, d0, they are not giving us any information, so we can assume that d0 is equal to 0. Okay. The initial velocity of Checo, we just calculated, and it's this one, the one in meters per second, 69.44 meters per second. Okay. Do we have the time? No. That's why we are going to solve this equation, this second degree equation, right? Okay, so in fact, we do not have it. Okay, we are going to continue with what we have. Okay, 1/2 of the acceleration. They are giving us the acceleration of checkpoint here. That is 4 meters per second square, right? So this is 4 meters per second square, right? And we have t squared, right? Okay. For doing this, for example, we will have to pass this 100 meters. Remember, for applying this formula for solving the equation, we need to put like all the terms in one side, right? So basically, we are going to have 0 equals to 1/2 and 4, it's 2, right? 2 t squared plus 69.44 e minus 100, right? This is like the shape of our second degree equation. Okay, now inputting these values in the equation, right? Our A in the equation is going to be, if you see, A is the one that is multiplying the term that is a square, right? So in this case, the ones that are multiplying the t squared is this one, right? Or in this case, like here, right? 2. So our A is going to be 2, right? B, okay, let's see our B. B is the one that is multiplying the t, in this case, is 69.44, right? And our C, what's the value of our C? Is a constant, right? And the constant, we can see that it's, I didn't put complete, sorry, I didn't, it was minus 100, right? Minus 100, okay. In this case, it's going to be minus 100, right? Okay, so basically, okay, we are going to like put it in the formula, right? It's going to be minus 69.44. This is our minus B, right? Plus minus, okay, B squared, 69.44 square minus 4 times 2, that this is our A, times C, sorry. Okay, our C is minus 100, right? Okay, it's going to be divided by 2A, and 2A, we said that 2 and A is 2, so it's going to be 2 times 2, right? After doing that calculation, let me go. It's going to give you like two values, x1, well, t1 and t2. In physics, we are just going to take the positive value, so we can ignore like t2. T2 is going to give us a negative value, and we are not going to take it. We are just going to take the t1. Like if you solve it, this full stuff, you are going to get okay. This time is the time that Checo like will cover the last 100 meters, right? Okay. If we want to continue, I will not like continue, maybe tomorrow, like not now, because if not, we are going to lose a lot of time, because we all now need to do that with Hamilton and like to see like the times and start like doing the calculations and like that, right? But well, that's maybe for tomorrow, or maybe even for after the exam, because I think that it's more important that we focus on problems that are close to the exam. This one is above the level of the exam, so don't worry too much about that, at least for the exam, no? Maybe later we can solve this problem for the homework, but well,
Teacher, hello.
yeah, sorry, what?
I have a question.
Yeah.
What so that formula? What's the use of that formula? The one of dt initial distance.
That's, for example, you are going to use this formula, like you can use it like in many cases, not just this one, right? But when you have uniform acceleration, right? And they are giving you like the distance, they are giving you distance and a movement with uniform acceleration, right? You are going to need this formula. It depends on what they are asking you, right? Because in this case, for example, they are giving us a distance and they are not giving us the time. But if you remember, like there are some cases that they are giving you basically everything. They are giving you, like, if you remember this problem, okay, okay. This problem from the last class, right? In here, you also use it, right? For knowing like its maximum height. Because for knowing its maximum height, you will first like, or also for this one, like for both, you are going to use it. You remember from the last class, h of t is similar to d of t, right? It's equivalent because this is height, this is distance, and if you know like height, it's a distance, right? So
Yeah.
if you remember, you use this formula, like the d0 cross d0t cross 1/2 of 8t squared, right? You use this formula in this case for knowing after 5 seconds where is your object going to be. That's like one case. Another case is the one that I was showing you. Like when you do not have, you have like the distance, and they are going to tell you like, okay, you have the distance, you have an initial velocity, and you have an acceleration. But I want to know like the time, like the time in where I will be at that position, or they also use it like a lot. I want to know like the time of braking, like the braking time, like to know if I have, I don't know, let's say this is the 100 meters, right? And I need to like stop. And I want to know like the time where I will be stopped. Another application is another application of this is, for example, like you left something to fall, like an object to fall, right? And you want to know, okay, I want to know the position of this object after 2 seconds, after 3 seconds, right? And like that. Or the opposite. Okay, I want to know the time where this object will crash with the ground, right? Like if you left this object to fall, right? You want to know, okay, how much time do I have before this object crashes, right? That's another application that you can use. Basically, like you can use a lot of applications. I will say that when to use it, like in an exam, is when they are giving you basically acceleration. Well, the object has an acceleration. They are giving you like an initial velocity. And they want to know, like your variables, like the thing that they want to know is distance or time. Like that. If they give you, for example, if they give you these 3 values, for sure, you are going to need to use this formula, right? Or the other way, they give you A and B0 and T, you are also going to need to use this formula. When they give you acceleration, initial velocity, and distance, and they're asking you for time, you use that formula. Or the other way around. If they are giving you acceleration, initial velocity, and time, and they want to know the distance, you also use that formula. Basically, like for knowing distance or time, when you have an object with a constant acceleration. Yeah,
Okay.
basically are the 2 cases, I will say, like when you want to know
And-
the distance or the time with an
Are- Are the exams problems going to be like all of them are going to be about vectors and this formula, right? Or not?
no, well, no. For this exam, they are going to be about more like this type. Like there's going to be 4 problems about velocity, acceleration, right? Like the topic of this week that we cover, the concept of motion. The 4 problems are going to be about this. And this one, in fact, like this one, is like in a really close level from the thing that you are going to have in the exam. A little bit harder, yes, this one than the one in the exam, but they are going to be more or less of this level, and you are going to have 4 problems of this type, and they are going to be 50 points.
And the other 50 points are going to be about true or false questions,
True
right?
and false is going to be 20 points, and they are going to be 5 questions. And another 5 questions of multiple option, right? Multiple option, they are going to be 30 points.
Okay. Thank you.
Yes, basically they are going to be like this. 50 and 50, 50 of yes, true and false, and this multiple option. The ones that I put you like in fact in the homework, they are really close. Like for this part is really super close, like to the exam. This one, okay, let's I didn't see it like with you. This one, for example, it's also really close to the exam. And okay. Okay, and then put it. For example, also this one is really close to the exam, right? Okay. Let's do this one that is really close to the exam. In here, they want to test if you know like the difference with distance and displacement, right? Okay. Let's say you run in a circular field of a radius 100 meters 2 times. Okay, this is important that we see. The radius 100 meters, and they're saying that you're running 2 times, right? They are asking us for the distance and the displacement. Okay. If you remember the distance, it's like yes, in fact, it's what you cover. Like if you, for example, let me go. Okay. It can be of any shape, for example. Okay, let me see. Okay, for example, we have okay. Let's say that this is 20 meters, this is 15 meters. Okay. For example, if we run like 1 lap of this, right? The distance, it will be what you cover, right? What you run. So it's going to be 50 plus 20 plus 15 plus 20, right? So this is going to be 30, 40, 70 meters, right? The distance is going to be 70 meters, right? But the displacement, if we remember, is the 2 minus the 1. So if we start at point 0, right, and we finish in point 0, what's our displacement? 0 minus 0. So our displacement, right, is equal to 0 meters, right? Okay, now let's do the one that we have in the problem. Now that we know that, okay, it says in a circular field of 100 meters, right? A radius of 100 meters. In here, well, we have to remember the perimeter. What's the formula of the perimeter of the circle? 2 pi r, right? Okay, so this will be, okay, the radius, they are telling us that it's 100 meters, right? It's going to be 2 times 100 times pi meters, right? But this is just for one lap. But they are telling us that we run it 2 times, right? So this will be, okay, 2 times everything, like 200 pi, right? So this is going to be 2 times 2, 4, 4 times 100 is going to be 400 pi meters. This is going to be our distance, right? The distance is going to be this one. But our displacement, as I said before, okay, we start running 1 and 2 laps. We finish where we start, right? So it's going to be 0 minus 0, right? So our displacement is going to be 0 meters, right? Okay, so we have to look for the option that it says that our distance is 400 pi meters. Okay, in here, A cannot be because our distance is not 100 pi. B, okay, our distance is 400 pi meters. That's good. But it says that our displacement is 100 meters. So this cannot be also. Our distance, we know that it's not 200 pi. And I put the last option was this one, sorry. The last option, D, it says it's equal to 400 pi meters and a displacement of 0 meters. So in fact, this is our correct answer, right? Okay, maybe in the exam, they are going to test you something about that, about distance and displacement. So you have to know like the difference between distance and displacement. Okay, let's see number 3. We throw a book downwards with a V0. What can we say about its velocity and acceleration? Remember that when we say that an object goes up, when we throw an object up, right? Our V is positive, right? And when we throw it down, our V is like down, up, right? And if we remember our G, our acceleration in the of the gravity, it's always pointing down, right? So our acceleration in here is negative. Okay, so let's see what we have. Positive velocity. No, we do not have a positive velocity. We see we have a negative, so A cannot be. Also, we cannot have a positive velocity. Okay, we have a negative velocity, but it says positive acceleration. No, if we see the acceleration is negative. So our answer will be D, right? Okay, perfect. Let's see if we can solve like some problems closer to the exam in level. Okay, for example.
Mister,
Yeah.
can you upload the Word document because I can't use the PDF?
Yeah, sorry. Yeah, I forgot. I will do it like right now. Okay. It was in assignments. Okay. First of all, let me put the Europe. Okay. Let me see. Okay. Let me put the word. Fine. Okay. Okay. Mhm. Mhm. Okay. Mhm. Okay. Okay, I just posted like in the Word file also. Like you have PDF and Word, whichever you prefer. Okay. Okay, let me continue with the problem. Okay, let me just okay, for example, this problem is like really close from what you can have in your exam, right? Okay, well, maybe we can continue with this in order to do it fast. Okay, it says that you are running at 25 meters per second and you slow down for 5 seconds. Your final velocity is 5 meters per second. Okay, good. Let's say, first of all, this one, the 25 meters per second, is our V0, right? Our original velocity. Okay. Our final velocity, it says that is 5 meters per second, right? Okay. And we have a time of 5 seconds. Okay. If we remember the formula of acceleration, I will like put the formulas on the board, like for the exam, but I feel like you need to know like what does it mean each value, right? Okay. And how to use it. That was the formula of acceleration, right? The change of velocity divided by the change of time. Okay. If we remember, it was V2 minus V1 times 2 minus time 1, right? Okay. And perfect. V2 minus V1 over T2 minus T1. Okay. Okay. Good. The V2 is going to be, in this case, our final velocity, right? And our V1 is going to be our initial velocity. So we have that our final velocity is 5 meters per second, right? Okay. And our initial velocity is 25, right? Okay. Times 2, we know that it's 5 seconds. And well, we are going to assume, because they are not giving us T1, that this one is 0 seconds, right? So we are going to have, okay, this is going to be minus 20 meters per second, right? Divided by 4 seconds. And this is going to, sorry, 4, I don't know why it's 4, 5 seconds. And we are going to have an acceleration of minus 4 meters per second square, right? Okay, so if we with that, we just solve the first question, right? That it was the acceleration. We know that okay, so letter A, the answer is minus 4 meters per second, right? And the braking distance in here, Angel was asking. Okay, when do we use it? What do we have? We have V0, we have an acceleration, and we have a time, right? But we do not have a distance. So we are going to use the formula like the long one, using V0 plus V0 t plus 1/2 acceleration times square. Right. Okay. Our time, it was 5 seconds. 5 seconds. Right? Okay. Our V0, we said that it was 25, right? Okay. And our acceleration, we just got it from the last question, that it was -4 meters per second square, right? So basically, and D0, they are not giving us anything. So we can assume that D0 is equal to 0. So we have this, and this. So we just need to solve for our distance, right? So basically, it's going to be 0 plus 25 meters per second, right? Multiplied by time, that is 5 seconds, plus 1/2 of the acceleration, that is -4 meters per second square, multiplied by time, square, seconds, square, right? Okay. Like if you do it, if you solve it, the final value is going to be, do you have it? Or, well, the final value, it will be 75 meters. It's just like solving, inputting the values in this formula, and you will have 75 meters. So, okay, for example, we solve one problem, or like in this level, they are going to be the exam, or the problems of the exam, like this one. Maybe we'll take a shot. Then I will post it. Also, I will post like this recording. And okay, like this one, like the one that it was in the homework, like problem 4. I don't know where I put it. But this one, like this one, it's another type of problem that you can have. The one that we solve, like in this level, they are going to be like 4 problems of this level. So yes, I think that this homework is a really good practice for you. Most in this part, from problem 4 to the other problem, like the true and false, and the multiple options, they are going to be really close to what you are going to have in the exam. Well, I think that's it for today.
Profe,
Yeah,
¿cree que pueda subir las respuestas
of what?
de esto?
Yes, well, yeah, maybe for the part of the exam that is really close to the exam, yes. For the other ones, I think that you will have to like solve it for yourself.
Okay.
Yeah, because it's not like what's the point of the homework, but yes. Like for example, these ones, you are going to like solve it yourself. But yeah, like maybe the ones that are close to the exam, I will like post it like even the solutions, like the step by step. So you can like practice with these problems, like know how to do with them. But yes, okay, yeah, I will post it like later. Like this, the step by step. But yeah, like really practice. Like from problem 4 to yeah, to the end of the homework is going to be really close to what you are going to have in the exam. Okay, well,
Profe, ya nos podemos ir.
yes. Okay.
Bye,
well,
prof.
Bye. Thank you. And tomorrow we are going to continue seeing topics like reviewing. Okay. Bye.
Thank you, teacher.
Thank you, teacher.
Teacher, just one question.
Yeah.
The exam for the partial, it's on 7th, right, of
Yeah.
September.
On 2 days. Yeah, in 2 days.
And can you do it like tutoring today or tomorrow about it?
Yes.
Because I kind of get a little confused on the topics.
Yes, of course. I finished my master's class after 7, so maybe
Can we do it
7:20.
at like 8 or 7:30? Is fine, I guess.
7:30 is okay for me.
Okay, 7:30. We're gonna have tutorings about what we just did about like basically about homework 6.3 because that's what we're going to have at an exam, right?
Yeah, homework 3 you can upload it until Friday. But really, like if you can like solve the homework 3 like after problem 4, like problem 4 and to the end, you can basically do the exam. They are
Okay.
really close to what you have in the exam. I tried
Okay.
like to do it them like really close to the exam.
Okay. Thank you, teacher.
Okay.
Yeah. See you at
Bye.
7:30.
Yeah, 7:30 tomorrow. Okay.
Can you do it today?
Yes, today I can at 7. I don't know.
7?
Yes.
Okay, can we do it at 7?
Yes.
Yes. Thank you, teacher.
You're welcome. Bye.
Bye.